Sourcing the materials needed to grow crystals is becoming increasingly complex. Single crystal substrates form the basis of many advanced technologies by providing a continuous, highly ordered atomic structure which allows researchers to deposit thin films, fabricate devices, and study materials with precision. At PI-KEM, we supply a broad range of high-quality single crystal substrates, available in standard specifications or custom grown, and overall backed by a secure and reliable supply chain. Hi, I'm Georgia Wardle, Technical Specialist here at PI-KEM. Today we're going to be taking a deep dive into the properties and applications of single crystal substrates. You can also learn more about how PI-KEM can help you with your crystals research with high-quality single crystal substrates. Many high-quality substrates are produced in regions subject to restricted exports, trade controls, and geopolitical uncertainty. For many researchers, this has meant extended lead times and unpredictable delivery, price volatility, quality inconsistency, and increased administrative barriers. This has impacted both new and existing research projects, where consistency is key to achieving reliable results. Because we've actively managed and diversified our crystal supply chains for more than 30 years, PI-KEM is not solely reliant on unpredictable trade routes. Our long-term relationships with carefully selected specialist partners means that, even as some supply chains tighten, we're still able to supply many of the key crystals and substrates that our customers are looking for at the moment. So, what is a single crystal substrate? A single crystal is a very pure, uniform piece of crystal with a perfectly ordered internal lattice structure. This can then be used as an underlying layer onto which a film or coating can later be applied. There are several methods to growing single crystal substrates, but primarily it is done through a melt growth process, such as the Chorowski or float zone methods. Atoms from an amorphous liquid phase of a crystal attach onto a seed crystal, which has the desired crystal lattice arrangement. As the crystal solidifies, it replicates the seed's crystallographic arrangement and gives the growing crystal the desired orientation. By carefully engineering temperature gradients and the characteristics of the seed crystal, it's possible to grow single crystals with desired orientations and dimensions. The final crystal ingot can then be sliced into various sizes and shapes to produce the resulting substrate. So, what makes single crystal substrates valuable? Single crystal substrates have a monocrystalline structure. This means that there is a continuous atomic arrangement throughout the crystal without any grain boundaries, as opposed to a polycrystalline or amorphous structure. This uniform orientation ensures consistent properties throughout the crystal and also leads to many valuable physical and electronic properties. The lack of grain boundaries gives single crystal substrates high mechanical strengths. Grain boundaries are naturally places that are weaker within a structure, therefore monocrystalline structures give superior strength, making them less prone to deforming or breaking under mechanical stress, and this is vital for maintaining device integrity. The absence of grain boundaries also enables faster electron movement throughout the crystal compared to polycrystalline or amorphous structures. This allows for faster signal processing and improves the overall efficiency of high-performance devices. Single crystal substrates also offer excellent thermal conductivity. The ordered crystal lattice promotes efficient heat transfer, which helps dissipate heat in high-power devices, improving their long-term reliability. Many single crystal substrates, such as sapphire or silicon carbide, possess high optical transparency across a broad range of wavelengths. This makes them ideal for applications in optical devices and sensors, where minimal absorption and high light transmission are required. Finally, the consistent structure of single crystal substrates allows for precise and predictable introduction of dopants, which helps to tailor other characteristics for reliable and accurate device fabrication. Single crystal substrates are integral to innovation across multiple fields. They are the foundation upon which electronic circuits can be built, which enables the development of high-performance devices with enhanced capabilities. Some single crystal substrates, such as silicon, germanium, or gallium arsenide, have semiconducting properties, which means that their electrical conductivity is somewhere between an insulator and a conductor. Semiconductors can display a range of useful properties, such as passing current more easily in one direction than another, showing variable resistance, and having sensitivity to light or to heat, which makes them useful for building circuits, building microprocessors, and power electronics. The organised structure of the crystals enables epitaxial growth of thin films, where the coating acts as a template upon which the coating material can copy the crystal arrangement when deposited on top. This technique minimises defects and strains and produces film with superior properties. This can be used to produce precise technical films, such as when creating solar cells. Within photonics and optoelectronics, the unique optical properties of single crystals can be used to detect, generate, and manipulate light. Through emission, transmission, modulation, signal processing, amplification, and sensing, single crystal substrates can be used within LEDs, lasers, and high-sensitivity sensors and photodetectors. They can also be used within photonic integrated circuits, which are microchips that integrate multiple miniaturized optical components. Single crystal surfaces provide an essential, controlled environment for understanding catalytic mechanisms and studying how molecules interact, absorb, and react on specific crystal planes, leading to the optimization of surface reactions and the design of more efficient catalysts and mechanisms. The defect-free, uniform lattice of single crystals provides the stability and coherence required for quantum states, which enables precise fabrication of quantum devices, helping to support the next generation of superconducting technologies and advances in quantum computation, sensing, and spintronics. PI-KEM can supply an extensive range of bespoke and standard crystal materials, covering a broad range of crystal families. From metal single crystals, oxides, titanates and niobates, to galates, aluminates and doped crystals. One of our valuable suppliers is Peter Drost at SurfaceNet, based in Germany. Peter has over 40 years of experience growing custom and unique crystals. Having a European supplier for crystals means that we aren't experiencing the same difficulties sourcing custom single crystals as those reliant on trade-controlled growers. Our long-standing relationship with SurfaceNet and Peter's decades of growing experience means that we can guarantee both crystal quality and delivery service. Crystal substrates can be provided as wafers, balls, tiles, prisms, rods, or specifications can be provided to form unique optical components. Custom orientations can be provided, such as miscuts, where there is a deviation between the actual surface of a crystal wafer and the intended crystallographic plane. Surfaces can be finished as cut, single or double-sided polished, or prepared for epitaxy or optical processes. The purity of your crystal can be tightly controlled. This includes the introduction of dopants in order to modulate the characteristics and properties of your crystal. The dopant levels can be tightly controlled to fit your specifications. Finally, precision machining such as stepped, bevels or custom geometries can be introduced. Across all of these specifications, very tight tolerances mean that you can rely on your crystal properties. So why should you buy your crystals from PI-KEM? Our customers can request customized crystal compositions, doping levels, sizes, shapes, surface finishes, and lots of additional features. We can fulfill requests for small quantities and low volume complex orders, which is cost effective for research and R&D. Delays in sourcing high quality crystal substrates can slow research and jeopardize project timelines. Whether you require standard or custom grown substrates, our technical experts, in partnership with our trusted suppliers, will guide you through selecting the right materials, dopants, orientation, forms and finishes for your unique application, ensuring that your research stays on schedule. Our team will provide expert support, fast responses and access to reliable, high quality crystals from trusted suppliers. Contact PI-KEM now to discuss your substrate specifications or custom crystal growth requirements.